ठीक है, तो let's do it casual. Okay, don't be I think bothered by the cinematic pressure caused by this camera. Okay, so let's do as usual business. So what we are going to deal with today, the chemical bonding. So basically I will consider the introductory part of the chemical bonding, because this is such a big topic, complex one. There are many theories, many structures of mathematical and physical structures and theories are involved to understand the chemical bonding properly. But as for us to simplify for the young guys like you, I would put it much simpler. So just to clear what actually this business is for, chemical bonding. What do you understand by chemical bonding? So basically, chemical bonding is a whole business. It's a whole business to convert an atom to molecules, clusters, and a whole range of compounds. As you all know, by the beginning of the 19th century, once the atom was discovered and the people understood that there is something called atom is the ultimate and discrete unit of the build-up of the whole matter. So people, the first phase of 19th century, people investigated how the atom looks like, what is the structure, and in that pursuit you have in your high school training and I think intermediate level, you have studied many theories. The first model that you have learned of atomic model is what's model? It's the Thomson model, isn't it? Then Bohr's models, then Sommerfeld models, and there are all other models, finally concluding to a quantum model of atomic structures. This is why I am telling this, all this model of atomic structures means that until you establish what is the basic constituent of the whole matter, and you could not understand what is the structure of the atom, there is no business talking about chemical bonding. Once you establish what is the basic unit of the whole matter of the universe, and then you establish the structure of the whole atom, like how it looks like, how the atoms, electron, protons are organized, and what are the fundamental particles within it, which is in a nucleus, which is revolving it, what are the charges, which is elementary, which is derived. These kind of things when you understood, then it comes to that whether, as you have understood, the atoms in its pristine form hardly do exist. Atom can exist, most of the atom, it would be wrong to say that atom can only exist in a molecular state, because there are noble atoms who do exist in an atomic state, but most of the atoms do exist in a molecular states. They generally have a tendency to combine with any atom next to them and combine to give them the polyatomic, diatomic, or whatever as per their valency allows, and to form in a molecular state. So basically my meaning is to see that the atom, since you know, except the noble gas one, unlike the Dalton suggested, the atom cannot exist, can't exist independently. Means what? Except noble gases. This is very important to write. Except noble gases. Otherwise, they are trapped atom. If somebody comes, some fellow comes to me that, hello sir, this is an atom we have trapped in atomic, in inert gases form, and we have measured its quantities as an atom. So people may say, sir, you have told me that atom cannot exist independently, but he is the man who is telling that I have trapped the atom, how this could be possible? The fact is that in a natural state, atoms do not like to exist independently, except to the one called noble gases. Noble gases exist in an atomic state. So when atom converts to molecule, one thing to tell you, this is scale. If you consider the scale, this is called atomic scale. Atomic scale of matter. And when this turns to molecule, it's called molecular scale. And to clear your picture that how things varies, at the level of atom, at the level of molecule, generally what you will find, atom do range from less than half the angstrom to 2 angstrom. This is the range where atom do exist. And molecules? Molecule starts in somewhere in the nano range. Let us say consider the 1 nanometer to even micrometers. 1 micrometer, nm to micrometer. Means simply 10 to the power of the order of 9 meter to 10 to the power of manner of 6 meter. This is the order of molecular scale. This is molecular scale. Means that simple, when one or more atoms, like here is the atom. I am just trying to make a picture for you. Like there is an atom, there is 3 atoms. If they combine together in some way, any fashions, they may combine like this, isn't it? If they may combine like this, someone smart here will say these two combinations are the same thing because this is the linear combination. It's fine. Of course, this combination would be a different if it combines this way. It is a different. But once they combine, this is the atoms. And this is called molecule. It is not a given a known molecule. I am just giving a picture to understand how atom changes to a molecular scale. So when these atoms come to the molecule scale, they have to combine. And when they have to combine, combining itself means that there must be some sort of attraction among the atoms. Otherwise, why they will combine? Combination of these atoms will contingent upon the forces of attraction. Otherwise, they cannot stay for long. Suddenly, if they let's say in a gaseous state they are moving here and there, they have a Hapgood movement. At the moment they collide, but instantly they will split away. But they stick and remain sticky. That means they have got attracted for a longer region of time. So that this is attraction. So this attraction, this force of attraction, this I will call it this force of attraction. Attraction between atom is something called bond. This is called bond. This is something called. So simply a bond means the force of attraction among or between two atoms or more than two atoms. Okay, force of attraction. Now, this attractions may result in a various kind of pictures. Of course, here is also attraction. If the 3 atoms falls in a line and get associated with this, they just like a bead structure. So there is association. There is attraction. Attraction here. Attraction here. There is attraction here. There is attraction here. Isn't it? But this attraction is governed by something. So how this attraction will happen and to what extent any atom will be attracted to the next atom is something we studies under the title called chemical bonding. In another way, we can put a picture how an atom changes to a molecule and molecule of a fixed geometry and structure. This part of the chemistry understanding is dealt in a title, a subject called chemical bonding. Means how atom combine with the next atom, and if they combine, they have any specific choices or preferences to result into some specific form of molecules, shape of molecules, type of molecules. As you people also know, the structure, the geometry and the form and the atomicity of any molecule determines its overall structure. So this is very important to understand that how actually chemical bonding happens. Means how the atom, how the 2 or more than 2 atoms begin to combine and how they ultimately end up into and what they end up into. So there are theories as you have studied about chemical bonding. I will tell you, there are theories. You might have heard at your school level, there are theories, something called octet. There are rules and theories. Octet rule, isn't it? Second, you have probably heard of valence bond theory, isn't it? And then you have learned probably molecular orbital theory. Molecular orbital theory. Okay, and you have also learned probably Vscpr Rule. Vscpr Rule. See? Okay, these are the three prominent theories that deals with the chemical bonding. These theories try to simplify the picture of chemical bonding as a whole. Chemical bonding. Okay, and when may ask simply that why there are three theories, why not one? If we have to understand that how atom combines and what they ultimately end up into, so why do we need three theories? Because atoms and their basic structure of all atoms is same. So why there are three theories? There are reasons behind it. I will explain it to you. Suppose there are many questions to be answered in understanding how atom combines, why atom combines with itself or with another one, and to how many atoms a single atom can combine. There are these sort of questions, and if they combine, what ultimate structure it would be. These three questions has to be answered. The questions to be answered: chemical bonding. I am telling, chemical bonding seeks answers to the question. Answers to the question like why atom combine. I am writing just why atom combine, how atom combine, and how many atom can combine. How many atom can combine? And if they combine, what the structure of the resulting molecule would be? Structure of the molecule. And one more thing, if they combine, what is the strength of their combination? Strength. Strength of combination means strength of bond simply. So chemical bonding overall have to answer all these questions, that why atom combine, how atom combine, and how many atom can combine, and structure of the, if they combine, what is the structure of the molecule, and if they combine, so what is the force of combination. All these questions has to be answered by a theory. And this is quite sad to say, all these questions cannot be singly answered by any of these theories, except the latest one that we call a quantum theory of chemical bonding, and to which you are not concerned with at this level, because it will go up your hair. You would not be able to understand quantum field theory and quantum theory of chemical bonding. So that's why these simple theories that for you people, is there not a single theory that can solve the question. And let me tell you how these questions and how these theories are relevant to. The thing is that a single atom, why any atom combines and how many atoms can combine, can be addressed by this octet rule. As you have heard that any atom combines and combines in a manner that whether it exchanges the electron or shares the electron, means that you are the ionic bond or covalent bond, the primary bonds, combines in order to complete its octet structure of the valence shell. Octet is why octet structures? Because the octet structure are the structures who are considered the cold closed electronic structures, like the structures of the noble gases which are inert. So it is like to whether they to quench their thirst. When there is no more than or less than 8 electron in the valence shell of any atom, the atom is thirsty of attaining the 8 electron in its outer shell. This is the kind of behavior is shown by generally mean group elements. This is also have to be a clear demarcation. You have to understand this octet rule is just valid for mean group elements. If you go to higher elements like transition metal elements, like elements of lanthanides and actinide, these rules of octet kind of rules will not be valid. Okay. So this answers that why any atom combine. It is in order to attain the octet structure of this valence shell in order to stabilize themselves. Okay. Second thing is, it can combine with how many atoms. This is primarily being answered by Valence bond theory. Valence bond theory, as you say, if there is a 3 electron in, if there is a 4 electron in its outer cell of any atoms, like carbon has a 4 electron in its valence cell, so it can combine with, either it can give all its 4 electron or can attain its 4 electron extra electron to attain its 8 electron in the outermost cell. So carbon better prefers to share its 4 electron with another atoms to complete its octet structure. So that's why it can only in a normal situation can combine with the 4 atoms or the 4 electrons of any next atom to attain the novel octet structure. So this is kind of theory which addresses the question that how many atoms any atom will combine with. This is the theory of the molecular orbital structure, that whether it's when the atom combines, what actually do combines. Since you know, after the 1925 or somewhere, if I am not wrong, after the very hypothesis of de Broglie got accepted and the dual nature of electron got into picture, so people got confused that how it combines. Electrons are wave as well as the particle, so what is the meaning of combination or exchanging electron? There must be some other theories. So that theory which is premised on the wave nature of electron, so here we call the electron, which also represent a wave, a matter wave, they have a combination. They have a combination with the next wave, electron wave basically. So in a simpler way, generally you will find that the orbital combination, the combination of orbital in some fashion, like linear fashion that most talk about. So this is the way that molecular orbital theory deals with. Okay. So these are theory dealing with these 3 questions. And one more question I want to add, the structure of the atom. When atom combines with any other atom, what would be the structure of the next atom? So this part of the question is concerned by this valence bond theory, which also includes a hypothesis. I am writing I am using the word very carefully, a hypothesis called hybridization. Hybridization. Valence bond theory uses a concept or hypothesis of hybridization. Based on this hybridization, valence bond theory is able enough to tell that how many atom will be associated with the central atom, which is leading the structure of the resulting molecule in the whole process of chemical bonding. So hybridization is a very important thing. But hybridization itself is not very completely able enough to predict the structure of a molecule once they got combined. So that's why we need an extra rule, and that rule is a Vscpr rule, Vscpr rule. This rule helps the hybridization theorist that to give a complete picture of molecule. Let's say if there is a molecule called methane, you all know methane. What is its structure? Its structure is tetrahedral. Everybody knows, isn't it? Hybridization is sp3, structure tetrahedral, bond angle 109.8, isn't it? If I call NS3, what is the hybridization at nitrogen atom? sp3, isn't it? sp3. What is the geometry? Tetrahedral. What is the shape? What is the shape? Shape of this ammonia is what? Pyramidal, isn't it? What is the bond angle? It is exactly 109? No, it is less than 109. Sorry, it is less than 109. How this could be explained? Both these molecules, NS3 and methane, involves sp3 hybridization. sp3 hybridization. They have a tetrahedral geometry, but they have a different structure. Just because of one atom is missing in this case, it is just a lone pair. And here is an atom, and it is just a lone pair. So due to this lone pair availability, is not gives a new shape to the geometry called pyramidal, but also affects its bond angle. So this bond angle and this bond angle is not same, it is 107 degree. So how this change can be accounted of? So for this we have a Vscpr rule. We have a certain set of rule, and this rule consists something called bond pair and lone pair of electrons, and they have a different electrostatic interactions. There are magnitude of electrostatic interaction of bond pair electrons, and bond pair and lone pair electrons is well calculated by the density functional theories, and that's based upon those predictions we can apply the conclusion of those rules, and we can predict that whether this bond angle is going to be a little higher than to this or lower than this. So this helps this. Okay. So these three, how many questions? Why any atom combines? It is basically answered by octet rule. How it combines? Basically is taken charged by valence bond theory, and how many atom can combine? This question also will taken by valence bond theory. And structure of the molecule, what will the resulting structure of the molecule? This question can be is generally answered by valence bond theory and with the help of Vscpr and hybridization. So basically Vscpr and hybridization come within the framework of valence bond theory. Valence bond theory is probably the form of work in the chemical bonding developed by an American chemist, a Harvard trained chemist, Professor G.N. Lewis, who worked all his life for the various institutions like University of California, Berkeley, MIT and Harvard. But he develops the valence bond theory, which is the central theory in the bonding, and it is still relevant and well studied of. Okay. So this valence bond theory you are more focused of. Once you will do with the valence bond, and octet theory is just a rule. It's just a rule, it answers a limited questions that why any atom combines, and that too it applies only to main group elements. And some may argue that well, no, it applies to even transition metal or even heavier atoms, but in a modified form. Because even the premise of this octet rule is to achieve the inert electronic configuration of the next atom in that period. So in that sense, if the main group elements are approaching the electronic structure of argon atom 8 electron theories, so there may be some neon atom. So some higher period elements may approach the argon, may approach the krypton, and may approach the other radon or other like of elements. So this theory means the spirit of this rule is not, of course, invalid even in the higher elements cases, but the rule per se is not valid. Somebody says it's not valid. Okay. And this chemical bonding, molecular orbital theory is generally a theory to deal with to accommodate the wave structure of the electron or atomic model. Also this is the latest one, and this have a strong bent on quantum mechanics. So basically at this level you people are not having a basic introductory knowledge of quantum mechanics, so this is irrelevant, but yes, of course you can also understand combination and all these things at level develops. Okay. So if I tell you little bit about valence bond theory, come directly. Valence bond theory. Let me develop a network. This is a hydrogen atom. Okay. This is a hydrogen atom. Let me picturize this. This is the nucleus, this is the nucleus, this is the electron. This is the electron. Isn't it? Whether hydrogen atom exists in atomic state independently? The answer is no. Hydrogen atom cannot exist in an independent hydrogen atom state. Why? Why? Because it has to achieve the inert electronic configuration of the next atom in that period. So hydrogen atom will try to achieve the electronic structure of what? Helium. Helium has what? 1s2. 1s2. So hydrogen have just two chances. Hydrogen can achieve 2 electrons in its outer shell just by either giving 1 electron or giving, if it gives an electron, there is no electron, of course. So there is no chance. If hydrogen has a 1 electron, if it gives 1 electron to any next atom, it will become H positive, and that is nothing but is a proton, simple proton. So atomic structure is blurred. Even hydrogen, if it gives up electron, it is no more atom, it is just a proton, a subatomic particle. Okay. So it has no chance to give electron and to achieve this next inert element electronic configuration. What is the next option? If hydrogen receives an electron, it will become this one. This will of course get stabilized by this structure, but it retains a charge, and this charge will make it thermodynamically as well as chemically both labile. So again this objective is not because atom go into combination just to stabilize. It's like people marry to get settled. Okay, so it's like that. Okay, so what is the next option? If hydrogen atom shares its electron with the next atom, then its business is done. It will attain 1s2 electronic configuration and will get stabilized. So that's why hydrogen atom, what happens? HNH, if it picturizes, and here are the 2 electrons. Okay, this is called bond pair electron. Bond pair electron. Okay, this is the bond. This has happened in this case. Next, if I go to NaCl, look at the structure. How will be the combination? How would be the combination? NaCl, Na has how many electrons in this outermost? Na has a 3 as shown structure, isn't it? Chlorine has a 3p6 structure, balancer. It has 1 electron extra. The preceding cell has a 8 electron. If it loses 1 electron, it will attain octet. And if it attains 1 electron, it will attain an octet. So here is a right combination of the right business basically. If you give up an electron, if I receive an electron, both are done. So they have a good deal. So they will simply do NaCl bond is formed just because Na first what happens? Na changes, gives up an electron and becomes what? Na plus, and Cl receives an electron and becomes Cl minus. And if you can see, simply can see here, these are 2 charges, they are point charges. They of course will be attracted by what? Coulombic force of attraction. They have charge and they are just like a point charge. So they have simple electrostatic attraction. So they follow the same Coulomb's law, Q1 Q2 on R square, and they are bonded by electrostatic force. This is also called electrostatic force. Okay, electrostatic force. Business done, but this is not that simple. If you imagine how these bonds would have formed, then the process is difficult, of course. Any atom give up its electron, it is what is called as, it is the ionization of process, isn't it? If any atom receives its electron, it's called reduction of an atom, isn't it like that? If you can say that this is an oxidation and this is reduction, that's a different terminology. Even oxidation involves ionization. Okay, so this is basically a thermochemical process. This happens through a thermochemical process. Thermochemical process. Okay, thermochemical process, and this is what we call a cycle. There is named cycle, Born-Haber cycle. Is it Born-Haber cycle, if I am not wrong? Actually, I missed the term. What had Born-Haber process exactly? There is a Born-Haber. If I am forgetting the name, there is a cycle. There is a named cycle which is being followed by these elements, and that's how these bonds are formed. And this is the sharing is a different business. Sharing is a different. Here there is no ionization is involved. It is called overlapping of orbital. Here what is happening? Overlapping of orbital. Okay, it's called overlapping of orbitals. So you can simply say here this is a simple electrostatic attraction. Ionic bonds are what? Simple electrostatic attraction. Simple electrostatic attraction. And this is what is covalent attraction? It is a different kind of attraction. It is a different kind of attraction. If I expose to the real problem of the covalent bonding, you will be surprised to know that how they are bonded together. Here you simply can see Na is positively charged, this is negatively charged, there are opposite charges, and by nature of electrostatic forces, if there are opposite charges, they are attracted by the nature. There is no issue. But in this case, if I ask you a question that this is a nucleus, this is a nucleus, this is an electron and this is the electron, and electron has a repulsion, then how they got associated? Once they got said, how they can get attracted? Is it interesting or not? So that's why this required a different, this is governed by thermochemical process. I am sorry, I am forgetting the name of that cycle. Although the resultant equation is a Born-Linde equation, I remember, but actually very famous. It's based on the first law of thermodynamics, and there is a whole derivation of that cycle. It's very important. It's important for even secondary student, for undergrad students as well, and postgrad student as well, if I am not wrong. But this is governed by whole thermochemical process, but this is governed by the other processes. Here is the concept of lattice energy. This is the business of inorganic molecules. These molecules, by all measure, they will be water soluble molecules. Here these molecules are not may not be water soluble. They may prefer to organic solvents. So this bonding and this bonding, primarily bonding is of basic category. The basic category of the bonding is of two types. Even it may be given in the range, but the atomic bonding or the molecular bonding level of atoms, these are basically two types. The one is electrostatic attraction, doesn't matter how many, what is the magnitude and what is the things are there. Another is a covalent bonding, where the orbitals are involved directly. Okay. So for this theory, there is a different, this concept of lattice energy involved here. And for this theory, there is something called these valence bond theories and molecular orbital theories. These theories help to understand this structure, isn't it? If you try to understand how these two electrons come together, an atom may combine, because electrons have the same charge, they have a repulsion. Is it interesting or not? Then there will be consideration of what kind. I can just give you a magic here. Imagine these two electrons are repelled among themselves. Okay? These two nucleuses are repelled among themselves. Alright? But think of one situation where nucleus of the first atom attracts the electron of the second atom. Isn't it? And here the nucleus of this atom attracts the electron of this atom. So there is a pair of attraction as well. Two pair repulsion and one pair attraction. And it is an amazing thing to find that at a certain distance, this attraction overcomes the repulsion, and this is where the bonding happens. And that business and that drop of potential and that whole story is being well described so beautifully by a wonderful work by P.M. Morse, a British mathematician. It's called Morse potential. This structure you might have heard of. Okay, this is the structure. This is the internuclear distance R. This R is the internuclear distance. And this ultimately comes to call as bond distance or bond length, Bn. There is an appropriate distance at which the potential energy will be minimum, and that would be a bonding state. Alright, so this is the different business and this is the different business. So I am going to give you a very simplistic picture of all kind of attraction that can be taken. Let me give you. Chemical bonding. Chemical bonding between atoms. How many possibilities are there? There is called ionic bond, covalent bond and coordinate bond. These three are kind of bond, 1, 2 and 3 are considered. This is a molecular bonding, and there are other kind of bonding. There could be a force of attraction and repulsion between the molecule itself, like the first, this atomic bonding or molecular bonding addresses the question that how atom combines with another atom and results in a molecule, and the further question arises how these molecules are associated with the next molecule to give the three states of the matter. Three states of the matter given by liquid, solid and what? Gases, it governed by what? Intermolecular forces, isn't it? These are called primary bonding. They are primary bonding. This is the primary force of attraction. Intermolecular forces, they are weak, that is why they call probably secondary. Okay, and these intermolecular forces can be of various kinds. Let me tell you. These forces can be of what kind? Ion interaction, ion dipole interaction, dipole ion interaction, dipole interaction, that we more popularly call London forces. Okay, these are kind of forces, these are called intermolecular forces. Okay. They are weak by nature. Okay, and theory to govern, they are governed in fact by the Lennard-Jones potential. On this, all bondings are generally governed by Morse potential, basically. Okay. So these are the kind of the molecular forces. The forces between the atom that leads to the molecule, and there are forces which are operating between the molecule that affects the next state of the matter. Okay, so one thing is clear. Chemical bonding is a business that deals with what? Chemical bonding is the business that deals with the why any atom combines to form molecule, and if it combines, how many atom with, and if combines with a given number of atoms, what would be the resultant structure out of many possible structure, and it combines, what would be the force of combination, extent the force of combination, what would be the directionality of that force. These things within the molecular framework are being considered by the primary bonding, the chemical bonding, for which there are theories that you often read in the textbooks. They call valence bond theory or molecular orbital theory, the two prominent theories. And there are forces also which are operating between the molecule. Once the molecule is formed, let us say you are forming ammonia. You are reacting with N2 plus what we call? You are reacting N2 plus 3S2. You are forming what? 2NS3, ammonia. And if this ammonia forms as a gas, isn't it? But you collect it as a what? Liquid. Ammonia you collect as a liquid. So here what happens where this bonding is in process? This is a molecular bonding. N2N2 bond, R2S2 bond are breaking up, and the new set of bond NH bonds are taking places. This process is thermodynamically governed. Okay, this is thermodynamic feasibility. Then that's why the process is happening. And when this NH3 is getting formed in that whole process, what it happens? NH3 begin to interact with the next NH3 that is already have been formed. And this attraction, this interaction is dealt by what? Intermolecular forces. And this intermolecular force, the magnitude of the intermolecular force, give the state of the matter. Like for example, NH3 is gas but water is liquid at room temperature. Why? Because the intermolecular forces between the water molecules is much higher than the intermolecular forces between the ammonia molecule. That is why the water is liquid at room temperature and ammonia is gas at room temperature. This is the basic two difference of molecular bonding and the intermolecular bonding forces. And these all forces, they are all physical forces originated on the substrate of the chemical, molecule, atoms, whatsoever, ionic species even, isn't it? The whole chemical bonding business is to deal with the molecular structure, order of structure, kind of structure, dimensionality, bond length, characteristics of bonds, and intermolecular forces deals with the state of matter, the characteristics of the matter that is being formed, the state in which it is found, the stability, and various physiochemical parameters. Okay? Alright, thank you for this, and I would like to end up today here. Okay? Alright.